Hello everyone, I'm going to take you through an example of the procedure that's involved in completely graphing one of these graphs, one of these functions, so that you will be ready to go and you'll understand exactly what I'm looking for on the quiz on Tuesday and the test on Thursday. So step one is to identify the x-intercepts. So for this graph, the first thing I'm going to do is I'm going to factor out a 3x squared. And that would leave me with an x squared minus 2. So based off of that, I know that my x-intercepts, if I set that equal to 0, would be 0 and plus or minus the square root of 2. The next step is to do the first derivative test. So I take the derivative, get 12x cubed minus 12x, set that equal to 0, factor out a 12x, which would leave me with an x squared minus 1 equals 0. And if I solve that, I get three critical points, three critical numbers, x equals 0, x equals 1, and x equals negative 1. So then I'm going to put that on a number line so that I can test the regions. Negative 1, 0, and 1. Okay, so then remember that when you do the first derivative test, you want to plug numbers from these four regions into the derivative. So if I take negative 2 here and I plug it into this derivative, negative 2 cubed is negative 8. 12 times negative 8 is negative 96. 12 times negative 2 is going to be negative 24, so I'm going to get negative 96 plus 24. So that's going to be a negative. Then I'm going to plug in negative 1/2. Negative 1/2 cubed is negative 1/8 times 12 is negative 1.5. This is going to be 12 times negative 1/2, which is negative 6. So I would get negative 1.5 plus 6. I'm going to get a positive. If I plug in a positive 1/2, I would get 12/8, which is 1.5 minus 6. So that's going to be a negative. And if I plug in 2, I get 12 times 8, 96, minus 24. That's going to be a positive. Okay, so now I have an idea what's going on. It's going down, up, down, up. Next step, second derivative. Second derivative allows us to test concavity. So I take the derivative again. 36x squared minus 12. Set that equal to 0. Factor out a 12. I get 3x squared minus 1 equals 0. If I factor and solve that, I'd solve this. It would bring the 1 over to, it's going to be plus or minus the square root of 1/3. Let's see, I need a calculator. The square root of 1/3. 1/3 is 0.33. The square root of that is going to be about 0.57, somewhere around there. So I would plug in negative square root of 1/3 and positive square root of 1/3. Okay, so if I plug that in, let's see, I'm going to plug in negative 1 into the second derivative this time. If I plug negative 1 into here, 36 times 1 minus 12 is going to be a positive. If I plug in 0, I get 0 minus 12. That would be a negative. And if I plug in 1, I get 36 minus 12, which would be a positive. So that tells me it's concave up, concave down, concave up. Okay, now I'm going to go ahead and put all of these things onto an xy table. So first I'll put the intercepts, 0, plus root 2, and negative root 2. Now these are all x-intercepts, so they're all 0 values. Next up, put a little divider line, I'm going to put the critical numbers. The critical numbers are negative 1, 0, and 1. So you can hear in the background today's announcements. So if I plug in negative 1 into the original, I would get 3 minus 6, so I would get negative 3. If I plug in 0, I get 0, and if I plug in 1, I get negative 3. And then I would plug in negative square root of negative 1/3, positive 1/3. If I plug that into the original, I'm going to get 1/3 times 3, which is 1. 1/3 minus 2, I'm going to get a negative 5/3. That's also going to be 5/3. And then the last step will be to graph. Wow, that's a bad line. To graph all these things. So I know 0, 0. There's 1. There's 2. There's 1. There's 2. So square root of 2 is 1.4. Negative root 2 is negative 1.4. Negative 1 would be negative 3, which would be down there. Positive 1 would also be negative 3, which would be down there. And negative 1/3 0.57 is going to be right about there. And that other one is also, wait a minute, I think I did something wrong. That's also going to be negative. So that's also going to be right about there. So then this graph comes down here, comes around, make sure you hit the intercept coming back up, and there's your graph. So that's pretty much all you need to know, and that's how you do it. So hopefully this helps, and I will see you in class.